Alright, so this is a Camworks Lathe CAM tutorial. This is going to show how to use basic turning features as well as live tooling and threading. We're going to be doing CAM for this FSAE wheel nuts. And the first thing we're going to do is define our machine as a mill turn, single turret for this because we're not going to do any subspindle operations. So single turret will be fine for that. Also, the post processor won't work unless it's a mill turn machine, so you can't set it up as a lathe if you're not doing any live tooling stuff. But always set it up as a mill turn. Select your post processor, and that's all you really need to do. Next, we will define our coordinate system. All you want to make sure of on this is that your Z is pointed away from where your chuck is going to be when you're holding your stock. So in this case, we want the Z pointing in the direction that it is. We could swap that if it wasn't. We're also going to set our origin as a stock vertex because we already have our stock defined, or I've already defined it, and I'm just going to do this front face here just to make it easy to pick up in the machine. Now we can go in and set up our stock. Just set it up as something bigger than your parts, and then you can use the offset parameters, or you can use the offset parameters to give you some extra material on the side so that the simulation doesn't have the chuck in the way, as well as give you about 10 thou on this front face so you have something to face off with in your first operation. From then we can move on to our first setup. We're going to do some turning features first, so we'll do a turn setup. Once again, just make sure your Z is pointing in this direction. And similar to mill features, we're just going to do turn features. And we want to do a face feature to start off with. It's always going to select rough and finish, but as long as you have like a minimal amount of material on your front face, you can just suppress the roughing pass. And it gives us these lines to pick from, which doesn't give us the face that we want, which is going to be this top face up here. So we can switch plane section to revolve section, and it's going to change this orange outline. Soon, I hope. There you go. And now we can select the top face here. And once we do that, okay. We can go to generate operation plan, and once again, we're just going to suppress this roughing because we have only 10 thou to take off. We have an 80-degree insert in a down left folder that is tool 1 for us. Move on to feeds and speeds. This is going to be made out of a medium steel. So our surface finish is going to be, or surface speed is going to be anywhere from, I believe, 100 to 140. So we'll be pretty conservative and do like 110 maybe. And our feed per revolution needs to be between 4 and 12 thou. So we're just going to do 5 to be safe. Distance to finishing, none of your profile parameters really matter as long as your allowances are 0. It does like to set your approach strategy and your retract strategy pretty far away from your workpiece. So a lot of times you'll have to set an approach point based off of the the stock diameter, you can just go 1/2 inch and 1/2 inch. Same with the retract. If you don't do this, sometimes it will throw X over travel error codes. We don't need a lead in or a lead out. The feature extensions, you can do this when you first define the feature you want to machine, or you can do it in this tab. All it is because we've only selected this very small line, that's all it's going to want to machine. However, we want it to face the entire part, so we want to extend along the X, and it's going to extend that way to the end of our stock. And then in the other direction, we can do along X and then reverse it so that it goes all the way to the center of our stock. And then that should be good for our facing feature. Maybe not. So I guess this is automatic. The facing feature will automatically do it without having your extend features, but we will have to use that later on for some other toolpaths. But now that we have run that, we can simulate our first toolpath. And it's going to face off our top for us. Next, we want to turn down some of the ID features, or the OD feature, the outer diameter stuff. So for that, we'll go back to this tab and do another turn feature. There's an OD feature, and we will select this furthest line here. And once again, we will extend in the Z this time all the way to the front of our stock. And then if we do the Z in the other direction, it will want to extend to the end of our stock, which we set as a couple inches behind it, which will cause it to run into the chuck, which we don't want it to do. So we're going to leave that off, and then we use some other constraints in the operation tab to get it to finish out where this taper is. We check that, generate our operation plan. We're going to use our where's the tool? It's already set as a 80-degree 1/2 inch insert, so we'll just change that to tool 1. Once again, we want our surface speed to be about 110, and we will do we'll do 5 thou again for this. We do want to do an axial cut. That means it's going to be multiple cuts at different X spots as opposed to different Z spots. And we want our first cut amount to be, we'll do 20 thou, just in case we have some non-perfectly round stock that sticks out and further in some areas than others. And then our max cut is going to be 25 thou. We'll set our last cut to be 0 so that it won't do any weird calculations to try and give us a 3 thou final cut, which doesn't really matter for a roughing pass. Once again, with the approach and retract strategies, we'll do approach points based on the stock diameter and the front face, 1/2 inch off. There we go. No lead-in option, or no lead-ins are needed. Let's see. So in order to get it to machine all the way down, because I think, yeah, if we preview it like this, it's not going to get the rest of our taper. So we are going to do a user-defined Z end, and then we can click here, click on this ring down here. We can do OK. And if we preview that, you're going to do it. Minus 0.5 maybe. If we extend it on in this direction and tell it we want to only go this far. There. Now it goes down to that plus an extra 1/2 inch, which we don't want to go a full 1/2 inch beneath. We'll go probably an extra 1/10 of an inch just to make sure. It's a negative. Negative. Okay. Preview, and now it should go beneath a 1/10 of an inch beneath this this line that we clicked on. All right. No. And for simplicity's purpose, we're going to use the same tool for roughing as we do finishing. And so we're still going to use that 80-degree 1/2 inch inscribed circle insert. Same feeds and speeds. We're going to turn the surface speed up a little bit and the feed per revolution down a little bit for the finishing pass. So it'll spin a little bit faster and move a little bit slower, which should give us a better surface finish. Once again, the depth of cuts are just going to be, these don't matter as we only have a 1/10 of an, or a 1/10 thou left over. So as long as these are set to 0, we're going to set our approach point. And our retract point. And let's see, going to do Z again, and then user defines this line minus 0.1. I can preview that, and that should be good. Simulate this. These are really small cuts. We may be able to speed that up here in the ends, but now our main outer diameter, our biggest outer diameter, it's been turned all the way down. And now we're going to do this smaller diameter where the castle part of the nut starts, which is just going to be another, I'm going to go back to this tab, another OD turn feature. Same as before, we're going to swap this to a revolve section, and we want that line right there. This is already selected as the tool we wanted. The same tool we use for all our other operations. Go back to 110. We'll do 0.006, a little bit faster. That way, while this is running, we can kind of fine tune and find what works for this material. We still want our depth parameters to be the same. We're going to leave 10 thou for the finishing pass. Redo our approach points. There's definitely a better way to do this. I just haven't looked into it yet. But this one, though, our line did go all the way to the bottom, so we don't want to extend in both directions. But just to make sure we don't plunge through this top little chamfer piece, we are going to extend in the Z that direction, and it'll extend to the end of the stock, so it doesn't matter. We don't have to do any extra limits over here. So now we can preview that, and that looks good. Also going to use tool 1 for this. Finishing pass, so we'll turn this not that high. Zeros. Go. And we're going to extend this in Z as well. And generate that. Now we can simulate again. And now the outer part of our castles, I guess, are green. And the final OD feature we're going to do before we start doing some live tooling and stuff is this top chamfer here. So as opposed to having an actual chamfer machining operation like you would in a mill, you can just do, I guess for this we can do a finish. You don't have to do we don't need to do a rough and finish just for this chamfer because it's only going to be 2 or 3 passes just to be safe. We can do it from our other tab here. We want the revolve section and do this chamfer line. And our tools already selected. Our feeds and speeds are still going to be 110 and 6 because this is a small cut. We just want to make sure we change our allowances to 0 since we're not going to do a finishing pass for this. And we're going to do same depth parameters just to be consistent. And this does not need any overrides or anything, so we can just preview that, and there we go. It'll knock this down, and then sweep across. All right. So now we have these text part of this that we have to machine, which can't be done with regular turning. We're going to have to use live tooling. So what we're going to do is give ourselves another setup. This time it's going to be a mill setup, and we're going to associate it with this direction. So like the mill setups, you want the arrow pointing as if you're looking down on your part, like that. And let's see. We don't want it to generate any other features for us, so we'll turn it off. We're going to go ahead and go over to this tab, and we have this use turn setup origin option for our origin now, which you wouldn't normally have in a mill setup. And basically all it's going to do is keep your origin the same as what it was for your turn setups, so you can post all of these together. But we'll go back to our mill setup, and we want a 2.5 axis feature, and we want this slot. We will just click on this, our end condition. We'll do up to face. All this has already been machined, so we just have to go up to this face here, and we want a rough finish. Generate an operation plan, edit definition. We're going to use, what do we have in our tool crib? Yeah, we'll use this 1/2 inch end mill right here. Yes. I believe this is station, no, this is station 11. Yep. Feed and speeds. Our SFM for milling. We're going to do, I believe it's 300. And we want our feed per tooth to be between 2 and 4. So we'll go 3. It seems pretty slow. So I'll turn this up 16 now. Okay. We will stick with 300. We don't want a cleanup pass. Our step over for this is going to be 10%, and we're just going to put in like an inch because we want to do it in one pass, or one depth pass, multiple axial passes. So if we try to, it will generate like this. If we preview, it should generate all the passes that you need. However, when you post this, it's going to try and do it using only X and C movements with no Y movements, which means it's going to like automatically calculate feed rates in the thousands. Uh, all you have to do to fix that is in the NC, change this free to fixed, and now it will calculate using X and Y feed rates and won't override you to like thousands in the feed rates. And can we rotate it from this? It doesn't look like it. Hit OK, and then we'll go back into here and do that for all. All 6 of these surfaces. Change it to a loop. I did this before. All I had to do was one, and it was able to calculate or figure out that I wanted to do the other 6. But mirror, do we have? See if I can figure out. Oh, we didn't open pockets. That's what the feature needs to be instead of a slot. Come on. I have to restart. So if you define it as a slot, you'll have to do all 6. But if you define it as an open profile, you should just have to do one of them. Maybe it's the loop. This one is just the one face. Open pockets. Rough finish. Up to face again. 300. No cleanup pass. 10%. Full depth of cut. Fixed. Now, if we preview, it does all 6 for us. Let's see what that looks like. Fast. That seems like a lot of extra movement. Offset roughing is probably what we want. Yeah. Offset roughing, or we can take a look at what polymill would do. Which looks pretty good, so probably stick with that. And then our finishing pass, once again, will be with the same tool. Turn that up a little bit and stay with our 0.03. Once again, I want to be able to go full depth of cut here. No bottom finish. Fixed. That looks good. So now, if we simulate everything that we've got, most of our outside should be done. Which it is. And so now we're going to start working on the inner diameter. But when I post this, I want to be able to do the outer diameter and then use my live tooling and then go back to like regular turning operations. And I want to do that because the live tooling does have a duty cycle for these machines. And because since it'll be the first time I'm running this program, I'm going to be starting and stopping and like looking at stuff a lot. It's probably going to get pretty far into that duty cycle. So it's going to require a cooldown, which means I don't want to slow down while I'm machining this. So if I turn everything I need to get to that feature, I can use the live tooling, machine it all out, and then while it's cooling down, or while it's in its cooldown stage, I can be using static turning stuff to do the inner diameters before I have to come back and use live tooling again for these pockets of the castle nut. And so in order to post that in order so I can make one big program, I have to do a second turn setup so that I can put it after this mill setup here. So we'll do our second turn setup, and it's just going to be the same as the first one, where it's Z pointing out. We'll go through and verify that the origin is the same, the stock vertex on that end, same as our first turn setup and our mill setup. Now we can start doing our inner diameter. So we want to go all the way from the center out to where the threads start, which is right here. So I can click that segment, but once again, I don't want to start all the way down there. Then I'll be plunging through all this material right here. So we'll go back and we will extend along the Z in that direction. And then we will extend along the Z in our other direction. And then we'll go back in and add stops a little bit beyond this bottom surface so it doesn't try to drill all the way through our stock. That's operation plan. Oh, we did not set that as an ID feature. Can I change that? I cannot. So we will look at that. So you do have to switch between OD and ID features. It can't intuitively figure out that you're on the inside of your part by clicking that line. So that's a little bit of a pain, but all you have to do is swap between ID and OD. And we want to rough finish it. The rough finish will give you generate you a toolpath for a spot drill, a drill, and then a rough bore and a finishing bore, which is what you need. Oh, why didn't it say my feature? Go along Z, reverse, check, generate operation plan, and there we go. We have all our features there. Here are our operations. So our center drill, see we have using tool 5. We'll select that. Still going to go SFM, and we're going to do 90 drilling. SFM for medium steel is going to be anywhere from 80 to 110. And our feed per revolution is going to be 8 thou for this. Center drill. Because we're going to be using a chamfer mill instead of an actual center drill, so we don't have to go as deep. Let me put our start point is going to be definitely this flat surface there. Okay, preview this. Yeah, it's going to want to try and drill that deep. We don't want it to. So we can override. That's got to be. We only want to go 50 thou from the top. And I've been forgetting to for the ID stuff, we don't want to do the stock diameter. We're going to do the setup origin, so to still put it in the center for us. And we can leave that as 0 for the X. Same for this, we just have to change 1/2 inch from the stock. Now, easier to find. Preview. Let's see. -25, that's right. There we go. And we want it to be -0.05, I believe, which will give us, yeah, just a little spot there. Just make sure I don't actually 0.7. I don't know if it adds the. So it has to be 0.5. Oh, there we go. And that should be all we need for the spot drill. The drill that we have is going to be 1 inch in diameter. So we'll see if that stayed in our tool crib. It did not. So we're going to change this to 1 inch. Station, I believe it's station 3. And that should be good. Feeds and speeds, operation, SFM. We're going to stick with 90. And our feed per revolution is going to be 0.01. We want a constant PEC. We want the approach point to be the setup origin and 1/2 inch from the stock. And we want to do X and Z, and then Z, then X to make sure that we're clear of our part when we're boring in it. And we'll add the tip length. And this one is also going to want to start at the line that we selected. So we're going to have to tell it we want to start all the way up here. That's the Z end, I'm sorry. So I might have been doing that for, may have to go back and check. The other one, we'll select that as our Z end. And then we're going to go an additional, we'll go 0.1 just to make sure we have plenty of clearance for the boring bar. And our start, oops, is going to be this top surface here. We'll see if that did wanted. It doesn't look like it went beneath the way we wanted it to. I'll slow it down. It started where we wanted to, that's for sure. But it did not finish deep enough. Probably just a negative. No, maybe this one does have to be positive. That, that'll work. Well, it's too far, but that's gonna work. There we go. Now we're drilling about 1/10 of an inch beneath our part, which should be enough room for the boring bar. Okay. Now, to make sure with this one, yeah, we were messing around with the limit of the Z ends, so we're going to change that back to whip. Do this user defines as the Z start as the top profile here. Say okay. The feature options, it's going to go 50 thou deep. Preview. That is going too far. So now we can do user defined here and say that we want to end also at this top surface here, but only go 50 thou deep. Okay, preview, and that gives us what. And all I did was when I was originally doing this toolpath, I was working at Z ends, not Z starts. That's just a little mistake I made, but it's confusing that they have the end first. But that is going to get our hole drilled, but now we have to bore it the rest of the way out. So for that, we're going to use our boring bar, which is an up left is what we have. Our diamond insert is an 80-degree, but it is a 3/8 inscribed circle. So it's a little bit smaller. Once again, we're going to be doing SFM. We'll do we'll slow it down a little bit for this because it's not as rigid. Or no, we want the speed to be the same. We want our per revolution to be a little bit slower. Just because we've had some issues with chattering with that boring bar in the past. We do want the axial cuts instead of the radial cuts. We're only going to do 20 thou for these. Last cut 0. I believe 10 thou for the Yeah, we want X and Z, approach point, stock or origin from stock, 1/2 inch. And then we want Z and X, track point, set up origin, and from stock, 1/2 inch. That way to go 1/2 inch back from our stock before it moves in the X, which will mitigate any risk of a crash. Once again, because we're still working off of the line that was down here in the threads, we want these extended the way they are. But our Z end is going to be user defined. We're going to go down to this point, and then we're just barely going to pass it. Actually, a little bit less than that. And see what that looks like. Did generate. That give us something. I'm going to pause for a second, figure this out, and then I'll come back. All right, so I figured it out. For some reason, the override feature extensions were messing it up. It didn't like having the extends in the vertical direction or the Z positive direction over here. So by getting rid of that, it allowed me to generate the rest of this toolpath. And it ended right where we ended up still having to do the Z start and Z ends with user defined positions. We defined it as this bottom surface right here, and then we gave it an extra 50 thou to go down. And as you can see, it still isn't going to go beneath where we drilled to, which is this vertical line right here. So we should be good clearance wise, and we can move on to the finishing for which we're still going to use that tool 5. Operation do 100 and 0 Z then X. Approach point is going to be origin and 1/2 inch off the stock. Origin from stock 0.5. That's still going to be messed up because of this. You need to find the end. It's going to be that -0.05. Okay. User defined start. Be all the way up there. And now this doesn't want to generate. So I wonder Now I need it to go down. I go on the reverse. Now it works. Sweet. All right, well, there we go. Save yet. And we can simulate again. Make sure everything is still green. All right. So now we've got our smaller inner diameter bored outs, but we can also bore out this blue here in between where the threads are and the rest of the castle parts. So that will be another ID feature in our second turn setup. This one, we still have to do rough finish. We can just suppress the center drill and drill that's going to generate with it. So I got to select a feature. We're going to do this chamfer and this vertical part at the same time. And we won't need to extend either of these. Generate an operation plan. We don't want center drill or the drill. We do want a rough and tool 5. I can't remember if we do 190. It shouldn't matter too much. Want our max cut to be 2.0. We're gonna leave 10 thou. I'm gonna set this at 0.2, but I believe it's gonna base this off of the drill that it originally generated with us. So it's gonna try and cut air that we've already machined out from the previous operation. And so we'll have to come back and play with our first cut amounts so that it starts about where it should. Let's see the next approach point, origin, stock, half an inch, retract point, origin, stock, half an inch. We shouldn't have to do anything with this. Okay, so it isn't going to try and do it based off of the drill, which saves us a bit of work there. So now that toolpath is good to go. And we're going to use the same tool. Ortho 0. Now we're going to use tool retract point. We gotta still set this there. And the rest of this should be good. Yep. Okay. Now everything should be good except for these little slots here, which is going to be our second live tooling operation. And then we'll part it off and do the rest of it in Op2. So we will need another mill setup here on the same plane. We don't want the face or perimeter. And yeah. Now we want to do a 2.5 axis feature, and we're going to set this as an engrave feature, and that's because this is a 1/4 inch gap here, and we want to machine it with a 1/4 inch ball and mill. And if we set it as a pocket or a slot, it's not going to be happy with us doing just one pass like that. It's going to want to have a pass one direction, a step over, and then a pass back. That's just the way it likes to generate those features. But if you tell it it's an engraved feature, we can just click this bottom line, and it's going to take the center of our tool along that line, and we can set how many depth passes that we want to take to get to that line. So our end condition is going to be up to this face here. To generate an operation plan. We have a 1/4 inch ball node. So we're going to have end diameter is 0.25. There we go. And our feeds and speeds for this are going to be significantly lower. But I don't have them off the top of my head because we're going to have to use, we only have a high speed steel ball mill. And so I'll have to come back and change the feeds and speeds for that. But our first cut amount, we'll do like 0.15. Our max cut amount is also going to be 0.15. This one, we should be able to leave as free since these are going to be in line with the center axis. It doesn't have to use any Y offsets. And that'll save us some space as it will try and machine all of them on the turret side of it. It won't have to reach across the parts to try and machine the other sides. So we're going to try and leave it as free. It should generate correctly. And we are going to have a parallel lead in so that we don't accidentally plunge with our ball mill. And we can preview. That looks pretty good. May extend this to like 75% just to be sure. And it's going to take 3 passes, which isn't a whole lot. So what if we did like 80 thou? Just yeah, we'll see what that looks like. We can always stop it and change it if it sounds bad. Now we rotate. We cannot rotate this. It's not. Oh, I didn't save it, did I? 0.25. It is not tapered. Fees and speeds later. Eighty thou. Depth we cut. Lead in. Parallel. 75%. Okay. I don't know why it still says that it is a tapered ball mill. Now we just have to go in, edit this so that it does all of these lines. And there we go. So now unfortunately, it doesn't process by depth there, so it's going to add quite a bit of time. So far, we are going to say threading for the second operation, just because the way our threading tool is set up, the actual cutting edge of the insert isn't at the exact bottom of the tool, so you do have to have quite a bit of clearance beneath it for ID threads. And by just taking it out, doing it in the second operation, we won't have any material on the side of the nut, because the spindle is also, not hollow, but it's got plenty of clearance behind it. So that's why we're going to save threading for the second operation. And so we should be good to part off now, which is going to require a final turn setup for op 1, same as before, with the Z pointing in that direction. And let's see. We want to do a cut off feature. And we don't have a flat surface there to select. So, let's see. How did I do this? The other one, I got rid of that fillet and did a second copy of the part for op 2. I'm going to try and do it without doing that for this one. I will pause and work on that and then explain how I did it once I figure it out. Alright, so I was able to get this toolpath to generate, but I did have to do a little finagling. All I did was went in and I added a sketch on this bottom surface here from this point to the center line, and then I was able to use that sketch as my profile for the parting off tool, and from there generated an operation plan, set my feeding speeds there. You want to peck so that you'll break the chip and let it cool down a little bit. It does have this slowdown programmed into it that we can set towards the very end. It will limit your RPM so that you don't go flying off it, so it doesn't part off at whatever insane RPM it's at when it's trying to turn that close to the center line. So you can set that to where the last part of this cut will only turn at 250 RPM, which is nice. We set all of our approach and retract points. Since we're working on the outer diameter again, we did stock diameter and from stock. We did have to add this extra start length here because I defined my point. It'll automatically start at the outside of your part. However, it won't necessarily start at the end of your stock. So I added an extra half an inch to make sure we'll clear the stock, and I'll watch the simulation and make sure it actually does. We didn't have to do anything with the limits, and we can just generate it. And now it should part off if I have my stock manager. Oh, it's not gonna. So now you can see we added an extra half an inch. Now it's going to start feeding. The pink line extends a little bit beyond your stock, which means you're going to feed before you make contact with your stock, which is what you want. So now we'll give it one final simulation, make sure we have everything that we want for op 1. Which, if you look in here, that little edge should be green. There shouldn't be any red from us gouging. And now we can move on to op 2. So we're going to make another turn setup. However, it's going to want to try and use a subspindle operation, but all you have to do is click reverse. It'll give you this message. If you click OK, it'll flip your Z direction here, which will align with you taking this part out and putting it back in the spindle, facing the other way. Don't want whatever that OD feature is. All right, so now we can go over here and we're going to change our origin to the part vertex, and it's technically the back side of our parts. It's counterintuitive the way the pictures are set up here, but this point here will correspond with the point that you want to set your origin at. We can click OK. And now we want to turn our OD feature. We want to do this taper right here. We shouldn't have to extend it at all. We can just generate our operation plan. That one's got the tool we want. We're going to go back to tool 1 for this. The same one we've been using. 110, something like 6 thou. Cut 20 and 10 thou for the finishing pass. We want to do Z and then X, approach point, stock diameter, because this is an OD feature again. No lead ins or lead outs. Feature options should be good. No Z limits. And that looks good to me. Oh, it is kind of a big cut. Did I do that right? I did not. 0.02, 20 thou, not 0.2. There we go, a bunch of little tiny cuts. And we can make that a little bit bigger. That looks better. We're going to finish with the same tool. Use this tool 1 that we've used for everything else. Finish operation 115. A little slower. Zeros and Z to X, previous point, retract, 0.5, 0.5. And now we can generate that toolpath. So now we simulate all of this. Just got to do the backside first. Our taper should be green here. Which it is. All right. Now we can see if we can get this little taper here done. This is going to be an ID feature, rough finish. And it's going to be that. Okay, generate an operation plan. We don't need this because we've already drilled through. This probably doesn't warrant a finishing pass. We can just set our roughing pass to a 0 allowance, since this is basically just a chamfer mill or a chamfer pass. 100, 5 thou, allowance 0, 0, 2, 2. Approach point to the origin. It's an ID feature and half an inch from the stock still. Origin, stock, half inch, retract point. And there you go, it'll do it in one pass. So we could have just done a finishing pass instead, but it is all going to work out the same. And now we can move on to our last operation, which are these threads. So for the threads, we want, I think it's over here. Yeah, threading. But we want turn boring because these are ID threads, so you want to make sure you're using the boring tool for threading. Is that the right tool? We're going to add a new tool. Gonna do user defined. Yeah, there we go. Thread. These are both OD turning tools. Let me make sure I set this up correctly. Turning bore, threading. Create a new tool. Okay. See. Oh, this tool. It's going to be well, my threading program. So since I don't already have the threading tool set up in my tool crib, it's not going to want to let me generate from this tab. But we can still do it over here by changing this to ID thread, and then you want to select this edge here because in your operation tab, you'll be able to set the depth that you want to go in. So if you click this line back here, it will start back there and your threads will be too big. So this is the line that we want to choose. We're going to extend it in both directions and then limit it to where we want to be because we want to be able to start up here and end down here so we get our whole part threaded. Now we can go here, edit definition. This is the insert that we want. You do want it to be an end folder edge. If you do a side, I don't know what thread that would cut on a boring bar, but you want to make sure it's ends. Ours is up left for our setup. The RPM we can set, I believe, relatively slow. I'll have to double check on what RPM that's actually supposed to be. So I'll go back and do that later. We want our depth per cut. This is steel, so we want to be pretty small. I'm gonna do like 40 thou per pass. I went pretty conservative on a threaded part that I made earlier and still managed to chip the insert. So we'll go really conservative with our depth of cut here. Our pitch, this is a 45 by 1.5 millimeter nut. So I can just put in 1.5 millimeters and it will convert that for me. Thread depth, I will have to look up for 45 millimeter or 45 x 1.5 millimeter. You can just looking up 45 millimeter by 1.5 millimeter pitch. It gives me a thread depth of 0.812 millimeters. So 0.3 inches. I can put my document settings and make sure that that's actually what it is. I don't want that chamfer. We can leave a final cut amount for that. Once again, X and Z. Our previous tool was an ID, so we can use that. Set up origin, stock, 5. We don't want to lead in or lead out. And let's see. I guess we can set our start length a little bit higher just to make sure that we're outside of our part, because we don't have the Z limits that we had before. So we'll do like a 1/4 inch, and that'll make sure that we're up there. And then the end length, let's see what that looks like first. Yeah, the end length will have to bump up as well. We're going to go 0.8, see what that looks like. And as I mentioned before, the way our threading insert is set up, the bottom of the cutting tip is not where the bottom of the actual tool is, and it's not easy to touch off your tool that way. So odds are, if we set it to where it stops exactly where it needed to, we'd be left with like half of a thread up here at the very top, which isn't what we want. So we'll have it extend a little bit farther, but because we're doing it in the second operation, we should have plenty of room for all of that. And I believe that is everything. If we simulate our tool paths, the whole part should be green, except for some weird stuff with the threads because SolidWorks does it cosmetically, but the CAM tries to figure out what's actually been removed. So there we go. There is our finished part.